Hello, I'm happy to have you again in this Upper Room Talk when we have the pleasure to have Professor Maarten Boers. He will introduce his books is on data visualization for biomedical science, and we will discover his book across 4 examples of figures. The floor is yours, Prof. Boers.
Thank you, Isana, for inviting me again, and I'm happy to show you some stuff from my new book. First, I'm going to show you the title page, and I'm going to show you the figure without the letters in just a moment. So I wanted to have on my cover a graph, of course, and then I came across this graph, which was printed in the magazine Our Hospital prints for co-workers, news about the hospital and science and all kinds of things. And this graph was published there. So when I started thinking about my cover, I tried to find it. Of course, the magazine was lying somewhere around. But then I had to visit the hospital, and actually I saw the original in the hospital printed on a huge size, like the wall of a room. It was that big. So then I had all the data again, and I approached the hospital to say, look, could I use this figure for my book, and how much would it cost? And they said, well, we bought this work, so you can use it for free. So that was really great news. So in the book, there is a text explaining the figure and what it means, but basically the artist took histograms from the beginning of the epidemic in Holland, and he depicted various elements of this. So the yellow is the caseload, and the red is the hospitalized patients, and the dark red is the IC patients in the first wave, and the black is the deaths on the downside. And then he's made cumulative figures here and here, and the baseline has also some lines. And here, actually, in very, very small text, there is comments made by politicians about the COVID crisis. You can see text becoming visible. And actually, he wrote all this text by hand. You can see this.
Yeah.
February 19, February 21. All of this is handwork. And here you can see these cases. They're small circles. So it's really magical. I thought it was a magic figure, so it was very fitting for my book, and it has very nice colors. So there you are. That's the explanation of the book cover, which is printed in full inside without the letters, so you can enjoy it even more.
And you see that the artist wrote the letter. Is he an artist or a biostatistician?
Yes, he's an artist. He's not a scientist. He's an artist.
Okay.
So, but he's a quantitative artist because he likes these graphs, like I do.
Okay. Then we could move for the second figures, maybe?
Yes. So while I'm discussing, can you still see it?
Yes.
Yeah. While I'm discussing this, I'm looking up to my second screen, so it looks a little bit strange. So the second figure you requested me to cover, I'm scrolling through the PDF of the print, so that's why it's looking a little bit noisy. So this is a graph I picked up from a newspaper, from the Financial Times, actually, and I thought it was, on the one side, a very beautiful graph, so it's very attractive to look at. And then I thought, why don't I like this graph very much as a scientific graph? And that's because it is really very difficult to conclude anything quantitatively from it. So you cannot read numbers from this graph. Only when you look at the boxes. Here it says 393, and there it says 4947. Now you know that this line is 393 and this line is 4947. But if you have to do all that reading, the purpose of the graph gets lost a little bit, because the whole idea of a graph is that you can get a lot of quantitative information without having to read all the numbers. And there is no idea on how large this is. It's very hard to know, because you have to think, okay, if this is about 5,000, maybe then this is 5.5, 6. I don't know. There's no way of reading the numbers from the graph. And then when it goes down again, what would the proportion of the orange, which is Brazil, to the US be? We don't know. So the graph is beautiful, but it is more or less useless for scientific purposes. So I have provisionally named this graph type the barf graph, and barf is US slang for vomit, because someone is vomiting multicolors from left to right, which is maybe not fair to the artist, but no, we have to be strict in our guidelines. And then I made this graph as an alternative, which is not exactly the same data, but it's to show you the principle. Because if I would have had to replicate the graph on the previous page, I would have to do a lot more data processing. So I thought I'm going to take data from the European Center of Disease Control, which is formatted slightly differently. And instead of deaths, I took confirmed cases. But obviously the principle of the data is completely the same. And in this graph, I think it's a scientific graph because we can take out numbers from the graph if we want. So what I have here, the bars are the total number of cases from all the continents. And then I have split the information from the continents into line graphs. So, and the line graphs have a common baseline. So now I can say, oh, look, in July, America has more than half the number of cases Asia has. And if I really want to know how much this is, I didn't put that in. I would have to draw a horizontal line to here and say, oh, it's about 1.6 million. If I wanted to be exact, I could put in another axis here, but we don't need that because this graph is made as a sort of a general reference to see what's going on. So you have the lines to see what the patterns are in the different continents, and you have the bars to show you what the total is for all the continents. So see the difference between these two graphs? This graph is arguably less beautiful than the one before. So it's less art, but my book is about scientific data visualization, which has to look good. But the point is not to please you with the aesthetics. The point is to show you data in the most efficient way. And that is what the whole book is about, how to get the data across in the most perfect way so that the consumer, the reader, understands what's going on.
Without losing information.
Yes, so the two words that are, you know, the sort of the pillars of the book, which I learned from a guru from many years back, Bill Cleveland. He used two terms: clear vision, clear understanding. And clear vision is making the data stand out. As another one, Edward Tufte would say, making the data stand out means the information that is in your message, you want to show it in such a way that it is being received by the reader, make the data stand out. And clear understanding is telling the story in the data, making sure the reader goes along with how your observations unfold over time, or the relationship between different variables. So from this graph, you can only see, oh, look, it was a little bit, then it was a lot, and then it was sort of also a lot, but slightly less. And the contributions of the various countries differ over time. That's what you can get from this graph. You can say, oh, wow, that's what this graph, oh, wow. And you would say, okay. In the beginning, it was not so much, and then all of a sudden, boom, the cases start, and the cases first start in America and Europe, and Asia is much later coming along, and Africa and Oceania do not contribute to the total at all. So it's perfectly clear, I think.
To finish, could you comment a last and an oldest graphs from Florence Nightingale Rose chart?
Yes, the rose chart, the famous rose chart. I have to scroll very quickly to get it in view.
It seems like Italian camembert.
Yes, this is the rose chart. So Florence Nightingale used this chart to go to the British Minister of War during the Crimean War in 1855 to show the effects of battle on soldiers, how many soldiers were dying of battle, and how many soldiers were dying of other causes. You have to really look closely to understand, but here's the explanation. The blue wedges for each month, measured from the center of the circle, represent area for area the deaths from preventable or mitigable zymotic diseases, which is mostly either starvation or infectious disease. Mm-hmm. And the red wedges are the center, the deaths from wounds, and the black measures are the deaths from all other causes. So what she's trying to show month for month is that the blue wedges are much larger than the red and the black wedges, which means much more soldiers are dying from preventable causes, which do not include the actual battle itself, but all the stuff surrounding it. And she's making the case for more healthcare during the war. And with this graph, she convinced him that more effort needed to be put into hospital care for the wounded. And so it was a great success. Unfortunately, this graph is highly misleading. In a way, the quantities depicted are, if you want, for July, they are this line and this line. And then for August, they are this line and this line. And for September, they are this line and this line, and so on. So in fact, this is a bar graph drawn in a circle. But now because we make the bar into a wedge, and the wedge can become larger because, well, obviously there's more stuff going on. Now our eye is saying, this is the quantity that we're looking at, not the line, but the area. And that makes our interpretation of the quantity, it is something to the square. So instead of saying, okay, if this is 100, that line, then this should be something like 200 maybe, so there's twice as many cases. But our eye says, no, there are 4 times as many cases. So this one is really way too big compared to this one. And our brain thinks, oh, wow, look at that. This is really horrible. All these people dying, which is what she wanted. So in this case, it was misleading for good causes, but we want in our scientific graphs not to mislead. So this is not a good graph form to take to your next scientific meeting if you want to inform your colleagues and not mislead them.
Okay, so to conclude, what defines for you a good scientific graph?
A good graph is made by someone who knows what the message is he or she is trying to send, and then conveys that message in a graph form, in a visualization. And actually data visualization, not just graphs, it's also tables. So sometimes you can say, no, I have to put this in the table because the message will become more clear. You know your message, you know your audience, and then you think, what is the best way to visualize this data, this message in a visualization? Once you have made that choice, then you start making all kinds of choices to make the data stand out as much as possible, which is clear vision. And then finally, you have to order your information in such a way that it becomes a story. And then once you have done that, your graph or your visualization is perfect.
This book comes with a wealth of support material that are available for download on a dedicated website. You can also check it out directly on your screen. And as a service to teacher, the author makes many titles available free on inspection. The link to order is in the description. Thank you for watching and have a great day. Hello.
Wait. Let me. I'm going to put on my other glasses because these are my stupid computer glasses. So this way I look more like I look when you meet me. Okay, let's start again.
I have
break.
No. I have also the same deals. So I will put off my glasses.
Now you're going to take them off. I can do that too, but then I look very strange. Okay, go.